Hello, and in this video we're going to talk about a little bit about Chapter 4. We're going to do part of it. The first part is going to be dealing with discrete random variables and the probability charts that you can use to describe discrete random variables. So a discrete random variable basically is a variable that is countable. That means it's something that is going to be able to be a whole number or some value that we know that's countable. Okay, so it's not going to be a continuous. Continuous is the other type of variable. Continuous means we can put any kind of value in between. So like a continuous value would be a measurement, where a discrete is a countable number, something that we can just get a representation by counting. All right, so when we create a frequency table and we create the relative frequency, this relative frequency is what we call the probability frequency of the table, as long as we are using very large numbers. Okay, so if we're doing very large numbers, then we're going to generate a probability distribution function using this relative frequency, the relative frequency of this discrete value that we put in X. All right, so two things. All the probabilities have to be between 0 and 1. And all the probabilities have to add up to 1 on that side of the chart. Okay, so here's an example of a probability density table. All the probabilities are listed here from 0 to 5. That's all the choices in this problem. And it gives you the probabilities of each of those here. If you were to sum all of these up, you would get 1. All the probabilities are between 0 and 1 here. So this makes a probability density function. All right, so what we're going to be doing here after we create the probability density function is we're going to be using that to answer probability questions. Okay, so two of the questions we might ask here is what's the mean of this function? And what's the standard deviation? All right, so we have two formulas for those. There's a way to do it in the calculator. I'm going to show you both things tonight in this one video. Okay, so let's say we have, this is the formulas for the probability distribution tables. So remember, the x's are the values that you would put in the chart from the values of the problem. And these are the probabilities for each of those values. Now, in order to get the mean or the expected value, sometimes they call it the expected value. So the mean and the expected value are the same. The letter they use for that is mu. What we would do is add up all the products between the expected value, between the value and its probability. So we'd multiply the two together, multiply these together, and then we'd add them up. That's what this sum symbol means. Okay, that would give us the mean or the expected value. To do the standard deviation, we have to use this number. What we would do is take every value here, subtract the mean from it, square that number, multiply by the probability, and get a value. So for each of those values, then you'd add that up and take the square root of that number to get the standard deviation. So it's a process, and we're going to go over. And then there's also a way we can just stick this into the calculator. It'll give you both the numbers just by plugging in x and p of x into your calculator. And you don't need to know the formula. So we're going to do it both ways. Sometimes it's easier to find the expected value just using the formula. I think the standard deviation is more readily used on the calculator because it is a little bit more intensive on the formula. But we'll do both. We'll try to do a short probability one, and we'll do both of those on a short probability one. So Let's say we find a probability. Here's the mean and expected value. It talks about them here. So we're going to do one of these problems from your book. Okay, and it shows you the process here, right? Here's the process. So finding the mean or expected value would be taking this times this value, getting an answer, this times this value, getting an answer, this times this value, getting an answer, adding these three values up would be the mean. Okay, now taking that number, 0, minus the mean, well, if we add these three numbers up, we get 1.1, and that's what happens right here. That's why they have 1.1 here. Take x minus the mean, square it, and multiply it by this probability here, and you get a value. You take that value 3 times for the different x's and the different p of x's. You put those in, you get 3 numbers, you add those up, and you take their square root, and you get the answer for the standard deviation. Okay, so that's an example of how to do that without a calculator. Okay, so you can do it without a calculator. You just have to create a chart. Create a chart of values, you can do that. Now, if you only have 3 values, it's not too bad to do it by hand. So when you have 10 or 12 values, or even this many, 6 values, here's an example of 6 values, right? So they went through the process of finding out x times p of x. They added these numbers up to get the total of 2.1. So they took 2.1 as your mean and did 0 minus 2.1 squared times 2 over 50, which is this decimal, and got a number. Did the same thing for this one, 1 minus 2.1 squared times 11 over 50, which is 0.22, and got a number. They did it again for each one of these values. They got all these 6 numbers. You add those 6 numbers up, and then take the square root of that sum to get the standard deviation. Okay? All right, so and that's what they did here. They took this. So when you add these numbers up, what you get is the variance. So if they ask for the variance, you don't take the square root. But if they ask for the standard deviation, you take the square root of that. So the variance is 1.05. The standard deviation is 1.0247 rounded to 4 decimal places. Okay. That's how you do it by hand. All right, to do it with the calculator, let's go over that, because most of the time, this is how we're going to do this quickly. First, I need a calculator. So we're going to verify this one using a calculator. All right, we're going to put these numbers in and verify it with the calculator and see if we get the same answer they've gotten. All right, so to do that, what I need to do is to open a new window and go to, what I need to do is go here, go to your calculator, because I don't have that written down anywhere yet, but we have a link to it right here on the top, right? Calculator instructions, here's the link. Click on 8 to 11, wait for it to load, click start twice, and then wait for it to load up here. Open that up, drag this off so it's not a window that's already there. We can have a separate window that way. Move this to the side. So now we have a calculator that we can use. All right, now we're going to use this on this problem. So let's go back to the problem. Open it up. Okay, here's our problem. So what we would do on this problem is we would put x and p of x in your stat table. So you hit stat, you go to edit, which is 1 or just enter. Since 1's highlighted, you can just hit enter. Okay, you're going to put 0 through 5 in. 0, enter, 1, enter, 2, enter, 3, enter, 4, enter, 5, enter. And then you're going to enter the probabilities. Well, you can just do the division here. Here are the probabilities, 2 divided by 50. So 2 divided by 50. It'll put the decimal in there. 0.04, which is what it says right here for p of x, right? Or we could just, since we haven't made this chart, we're just going to use the values here on these two values, because these two values are going to be given to you in the chart. This stuff you have to make up. So we're going to go 11 divided by 20. Oh, I'm sorry. Delete. It's not 11 divided by that. It is 11 divided by 50. And then 23 divided by 50. And then 9 divided by 50. And then 4 divided by 50. And then 1 divided by 50. Okay, so you enter in your x and p of x in L1 and L2. You go through the same process as if you were using your one variable statistics here. So you're going to calculate one variable statistics. You're going to use your frequency to be L2. So again, you're going to hit second 2 to put L2 in there. You're going to go calculate. All right, so it's telling me that x bar, which is the mean or the expected value, is 2.1, which is what they got here, right? They got 2.1. Here is the standard deviation, 1.02469. All right, and on this problem, they said the standard deviation was 1.2. Oh, they've rounded. So they didn't give you the variance, 1.05. Okay, but they did give you the standard deviation right here. Okay, so there's the mean or the expected value. Here's the standard deviation. You'd round it to 7 here because that's a 9, and that's what they did here. Okay, if you took this number and you squared it, you probably would get 1.05 or close. All right, so the calculator is a quick way to do it if you just entered in the data. You put that in your stats edit. You put your x's in the L1 and your p of x is in L2. And you run one variable statistics on it. One variable statistics, L1 and L2. Make sure you have L1 and L2 in there and then calculate. Okay? And it's the same symbols that we have here. So if we see sigma on the thing, so when I calculate this out again, right? Here's my sigma right here. That's telling me the standard deviation. It has the same symbol as they use in the problem. Okay, they don't use the same symbol here for mu. X bar is the sample standard deviation. But it's the same in this case. All right, so that's how that works. Now let's do a problem on your homework, because a lot of the problems, there's a problem here with how to do this with an application. Some people have a problem with the application problem. So let's pick the one that's always gives people problems here. So here it is right here. Here's one here, number 5. It says the student council is hosting a drawing to raise money for scholarships. They're selling tickets for $10 each and will sell 900 tickets. There's $2,000 grand prize, 2 $500 second prizes, and 15 $10 third prizes. You bought one ticket. Find the expected value. So that's just the first part where we have to do x times p of x and add them up. So you may not need a calculator. Well, you could use the calculator to multiply and add them up, but we need to generate the chart here in order to do this. They didn't give it to us in a chart like this. So they didn't give us x and they didn't give us p of x. So what we need to do is find out what x is. In this case, x is profit, because that's what it wants, your profit. Okay, so I'm going to go back to this problem. We're going to generate this chart. Okay, so we're dealing with profit here. Okay, so in this case, x is profit. And P of x is the chances that you make a profit. What's your chances for each x value that you would make a profit? Okay, now we have to list all the profits. So you have chances of winning and you have chances of losing, right? So there's 900 tickets. So your chances are you could win, you could not win, right? There's a likelihood that you don't win. So that would be a negative $10 profit because you spent $10 on the ticket, but you didn't get any, you didn't win. They didn't draw your number. Okay? Next, maybe you got a third prize here, third place. So if you win third prizes, you get $10 back. That means your profit is zero because you spent $10 and you win $10. If you get second, you win $500, which you spent $10, so that means you make a profit of $490. And then if you win the grand prize, that means you get $2,000, but you spent $10, so your profit's going to be $1,990. Okay, so this is the list of all the profits you can possibly make on this drawing. A negative profit is very likely. Okay, so if you win the grand prize, that's 1 out of 900. That's your chances. There's one grand prize, right? Second place, there's 2. So it's 2 out of 900 because there's 900 tickets. 2 out of 900. And there's 15 third place prizes. So you could, if you have 15 out of 900 to break even. And then what's left over out of 900 is what you have for not making a profit, making a negative profit. So what we would do there is take and add these up. That's 1718 and subtract from 900. So you get 800, 18, so 882 out of 900. 882 plus 15 plus 2 plus 1 is 900. Okay. All right, so those are our x and p of x. So to get the mean or the expected value, all we have to do is take negative 10 times 882 divided by 900 plus 0 times 15 over 900 plus 490 times 2 over 900 and plus 1990 times 1 over 900. So this is what we need for the expected value. So this is something we could do without plugging all these values into the calculator and hitting the one variable statistics because they're not looking for that. You're looking for what's your expected value. Your expected value would be how much profit you would make on this, possibly, if you did this lots of times. Okay, so let's take our calculator, regular calculator, and figure that out because it's just multiplication. All right, so we got 10 negative times 882 divided by 900. Okay, that's negative 9.8. So we're going to put equals down here. 9.8. I know that this one's 0, so the second one is 0. And then we'll do the next one here. So the next one's 490. It's clear. 490 times 2 divided by 900. We get, well, a long decimal, but it's repeating, so that's nice, plus 1.08 repeating. And then we need to take the last one, which is 1990 times 1 divided by 900. And that's repeating 2. Okay, so we're going to have plus 2.21 repeating. Okay, so let's do that. Okay, so we have plus 1.8 repeating. Put a lot of them in there. Plus a negative 9.8. So we get negative 6.5. So that means we're losing $6.50 each time, because this is in money amounts, right? So this equals negative 6.5, or negative $6.50. So we're losing $6.50. Overall, if we did this lots and lots of times, we would not make a profit. We would make a negative profit. So let's just check. I have the solution right here, but that's what they have, negative 6.5. So that's our expected value. So in this case, you have to generate your own x values, right? And your p of x values based upon prizes. That's always a question that's asked in this section. The rest of these are already drawn out for you there. Now this one is where they ask for the variance, right? So that's before the square root. Or if you get your calculator, you're going to have to square this number to do this one. All right, now same thing happens here when they're asking you something like this. This is going to be the next type. So this will be on the next video. So when we get to question 9, we'll start that on the next video.